Alright, in this tutorial we are going to go over division properties that involve exponents. So when you are dividing two different expressions that are in exponential form and they have the same base, you are going to be actually allowed to simplify the expression by rewriting the exact same base and subtracting the exponents. Okay, if you remember our multiplication property that we went over in the last tutorial, you have x to the a power times x to the b power, and those two same bases were being multiplied. You can simplify that by rewriting your base once and then just adding your exponents together. If they're numbers, if they're variables, doesn't matter. That's the property that you can use to simplify. So we're doing the exact same thing here, but instead, notice that the bases are being divided. They are the same thing, so you can rewrite them as a subtraction of your exponents, a minus b. And one thing you need to be careful of, especially with the subtraction property, is that sometimes you may be getting negatives in your exponents. Usually in the directions for these type of exercises, you're going to see express your answer with positive exponents. So if you end up with a negative in the exponent, then you need to use your negative exponent property and move that into the opposite position and change the sign to match what it's supposed to be. This first example is a really good example of that. So we have u to the negative third up top, u to the fifth in the bottom. These two things are being divided, so we can simplify this by subtracting u to the negative 3 minus 5. Since these two numbers are the same sign, you add the number and keep the negative sign, so this becomes u to the negative 8. And notice that because the order of subtraction matters, sometimes we may get a negative right here. We need to move this entire term into the denominator and change our exponent to be a positive. So this is how everything needs to be simplified so that you have your positive exponents. It's just in the different position. You cannot leave it as u to the negative 8 if the directions say positive exponents. Okay, second one, d to the 0 power over d. Now notice there is an invisible one right here. There is one exponent. This one up here tells you that there are 0. So a couple different ways. You can either simplify it the exact same way as we did the last one, same basis, so we can subtract d to the 0 minus 1, and we end up getting d to the negative 1. And then just like the last one, we have to make sure that we put it in the denominator so it becomes 1 over d to the 1. You can either write d to the 1. Eventually, however, I will start asking you to leave that one exponent off, and it would just be 1 over d. Or what you could do from here is notice that it's a 0 exponent, so this can be reduced by saying that d to the 0 power is just equal to 1, and we already know that this is a positive exponent, so we don't need to do anything from there. You are able to use your 0 exponent properties to simplify that term first before you subtract if that makes it easier, but you will end up getting the same solution regardless.